Section 3.7, Evaluating Determinants and Applying Cramer's Rule. So a determinant is a real number that's associated with any square matrix. So for example, in this section we're going to be dealing with 2 by 2, 2 rows and 2 columns, or 3 by 3, which is 3 rows and 3 columns. And the way you find the value of a 2 by 2 determinant is you're going to multiply the down diagonal, so A times D, minus that up diagonal, C times B. So if we look at this first example, 6 times a negative 4 minus 1 times a negative 2. So when we multiply these out, we get negative 24 minus a negative 2. Changing the double negative to a positive, we get that the value of this determinant is negative 22. And so now we have the value of a 3 by 3 determinant. So the first thing we need to do is rewrite those first 2 columns. And I'd like you to actually do this rather than visualize. Some of you that are good with your mental math might not want to rewrite these, but you're going to rewrite the first 2 columns. And then it's the same idea as with the 2 by 2 matrix. You're going to multiply all the down diagonals, so those that I drew the lines through, minus, and you're going to multiply and add all the up diagonals, so those would be the red lines going up. And so now again, let's look at this first example. The first thing we need to do is rewrite the first 2 columns, and then as we multiply the down diagonals, 4 times 1 times 3, plus the next down diagonal is negative 2 times negative 2 times 2, plus the last one, 0 times 1 times 5, minus now all the up diagonals. So 2 times 1 times 0, plus 5 times negative 2 times 4, plus 3 times 1 times negative 2. And now if we just multiply those out, our blue or up diagonals multiply to give us the products of 12 plus 8 plus 0, minus all our down diagonals, 0 plus a negative 40 plus a negative 6. So we're going to get 20 minus negative 46. Again, changing our double negative to a positive, we get that the value of this 3 by 3 determinant is 66. And so now we can use determinants. We've learned how to evaluate determinants, and we can use determinants for 2 useful applications. One, finding the area of a triangle, and typically the normal formula for the area of a triangle, if you recall, is 1/2 base times height. And so we're going to find the area of a triangle that doesn't necessarily have to be a right triangle. And we can also solve a system of equations, either 2 equations with 2 unknowns, or 3 equations with 3 unknown variables. So to find the area of a triangle, you are going to set up this 3 by 3 matrix. So we have our 3 ordered pairs, x1, y1, x2, y2, and x3, y3, the subscripted numbers just differentiating between the 3 ordered pairs. And you're going to list those ordered pairs in the first 2 columns. So if you'll notice, x1, y1 is the top row, x2, y2, and then x3, y3. And you're filling in to make this a square matrix. That last column is always going to be 1. Now, the 1/2 comes from the idea that the area of a triangle is 1/2 times the base times height. But why is this, plus or minus? I'd like you to write down an idea, and we're going to discuss this in class. But now let's go ahead and use this idea to find the area of a triangle with these given vertices. So again, the first thing we need to do is write down our ordered pairs, 10, 20, negative 8, 5, negative 4, negative 5. We're going to fill in that column, last column, with 1 all the way down. We're going to rewrite the first 2 columns, and then we also need to remember that this has to be plus or minus 1/2. So don't forget that plus or minus 1/2. And so now when we rewrite our first, or actually we've already rewritten our first 2 columns, we're going to do our down diagonals. So 10 times 5 times 1 is 50. 20 times 1 times negative 4 is plus a negative 80. and then 1 times -8 times -5 is a positive 40. So those are our down diagonals. Now we're going to subtract our up diagonals. -20 plus a -50 plus a -160. And so now we can just simplify all our parentheses. We still have plus or minus 1/2. And 50 plus -80 plus 40 gives us 10. And -20 minus -20 minus 50 minus 160 is a -230. Again, changing our double negative to a positive, multiplying it by the 1/2, and we get that the area is 120. Make sure we're dealing with area, so it's going to be units squared. Sometimes you might give that these coordinates are miles or inches, so you would just make sure that you would put the correct units there. And so the second reason we would use Cramer, or the determinants, is to use Cramer's rule, and this is to solve a linear system. So if we're given a linear system, ax plus by equals c, and dx plus ey equals f, keeping in mind that a, b, c, d, e, and f are real numbers, we're going to set up to find our x coordinate, or the value of x where these two lines intersect. We're going to set up a numerator and a denominator matrix. Now, I don't want you to memorize these as far as letters. I want you to always think of this as an x column and a y column. And if you notice in the denominator of both of them, it's the same matrix. And again, if you notice, I'm going to call this the coefficient matrix. So the A, B, D, and E are what gives me my denominator. For my numerator, when I'm finding my x value, okay, I can't use the x coefficients. So in place of the x coefficients, when I'm finding x in that x column, I'm going to put those constants. It's the same idea when you're finding the y. Again, this is going to be your x column and your y column. But when you're finding the y coordinates, you can't use, when you're finding the y coordinate, you cannot use the y coefficients. So again, in the y column, you're going to put those constants. So now let's go ahead and try to do an example. We have 6x minus 2y equals -16, and -3x plus 5y equals 16. So the first thing we're going to do, is set up our denominator, which is our coefficient matrix. So in my x column, I have 6 and -3. And in my y column, I have -2 and 5. And now we're going to set up our numerator matrix. So again, if we're finding x, if we think of this as our x column and our y column, we can't put those x coefficients. So we're going to put -16 and +16. And then in my y column, I can still put the -2 and the 5. So now when we're finding the value of our determinant, when I do my down diagonal, -16 times 5 is -80, minus my up diagonal of -32. And then on the denominator, my down diagonal is 30 minus 6. When I simplify my numerator, I get -48. My denominator, I get 24. When I divide this out, I get -2. Now we're going to go through and use Cramer's rule again to find our y coordinate. So again, we need to set up our denominator matrix. Well, our denominator matrix is exactly the same, so since we've already found it for x, we can just put +24 there. And again, since I'm finding y, I can't use the y coefficients in my y column, so I'm going to put the -16 and the +16 in the y column, and I can still put 6 and -3 in the x column. Denominator I can carry over is 24. 6 times 16 is 96, minus -3 times -16 is 48. And again, when I subtract these, I get 48 over 24, which is 2. So my solution is going to be -2, 2. And if you plug these values in to your original equations, you'll see that they do in fact work. And now let's take a look at a 3 equation with 3 unknown variables. So again, my denominator is going to be the coefficient matrix. So A, B, C. Looking at my first equation, E, F, G, my second equation, and I, J, K as my third equation. And then again, I'm not going to go ahead and write all these out, but again, when you're finding your numerator, so first of all, that's always going to be the denominator, whether it's x, y, or z, and you're still going to look at this as your x column, your y column, and your z column. So if I'm finding x, I wouldn't be able to use my x coefficients. In place, I would have to put my constants. And then the same with the y. You would put those in place of the y column when you're finding y, and you would put those in place of the z column when you're finding z. So now let's go ahead and look at an example. So if we look at this 3 by 3 matrix, the first thing, because these can get really big, let's first of all find our denominator. So again, my x coefficients are going to be 3, -1, 5. My y is going to be 1, 2, -1. And my z is going to be 1, -3, 5. So now I'd like you to pause the video, rewrite the first 2 columns, and find the value of your denominator matrix. If I look at my down diagonals, I'm going to get 30 plus, next down diagonal is -15, plus my next down diagonal is going to be a +1. Now I need to subtract my up diagonals. So my up diagonals are going to be, whoops, that's going to be a +10 plus 6 plus a -5. And this is one reason neatness counts, because as I drew that line through, I mistakenly took that 3 as a 2, and so I wrote down the wrong value. This should actually be 10 plus 9 plus 5. And now if we go ahead and simplify these, I'm going to get 16 minus 14, so my denominator matrix is 2. Now, mostly to save some room, I am going to erase all of my work here, so I can do all of this on one screen. And keeping in mind that my denominator matrix is 2. Now let's go ahead and set up to find our x. So first of all, let's not forget that we have a denominator, that's 2. And now if we set up our matrix, again thinking about this as our x column, our y column, and our z column, we can't use the coefficients in our x column, so I'm going to use the constants of 14, -9, and 30. And then for my y column, I can use those y coefficients, 1, 2, -1, and my z column is 1, -3, 5. So now go ahead and rewrite the first 2 columns and figure out what the numerator of your x should be. So again, my down diagonal is going to be 140 plus a -90 plus 9. And then my up diagonal, so minus 60 plus 42 plus -45. Keeping in mind again that this is still all over 2. So when I simplify this, I'm going to get 59 minus 57 all over 2. 2 over 2 is 1. So my x-coordinate now is 1. Now let's set up our y matrix. Again, my denominator is 2. In my x column, I can put my x coefficients because I'm finding y. My y column is now where I need to have those constants. And my z column, I can have my z coefficients. So now I want you to pause the video and go ahead and find the value of my y. So there's my down diagonals minus my up diagonals all over 2 still. So again, simplifying, I get negative 375 minus a negative 385 all over 2, 10 over 2, so my y-coordinate is 5. Now let's go ahead and find our z-coordinate. Well, since we have our x and our y, we can pick any one of our 3 original equations. I'm going to pick the first equation, and we can just plug in what we know for our x and y. So our x is 1, our y is 5, and we should be able to solve this for z. And my z is 6, and so my final solution, written as, again, an ordered triple, is going to be 1, 5, 6. And once again, you can check this by plugging all 3 of those values into all 3 of your original equations. This is not an easy section. One thing that often happens is students lose a negative, so as you're doing these problems, please make sure you're not erasing your work if you're not getting something that works, and I can see where you might have made an arithmetic error. And so please come to class with questions, so anything you don't understand. And make sure that you go back and do the notes check. And we'll see you tomorrow in class.